Welcome everybody. Welcome to my talk from Monolith Database to Microservice. Let me introduce myself. My name is Vladimir Dejanovic, and I'm a part of professional IT. What this talk is going to be about? First, I will spend some time about basically data and databases, and most of the talk is going to reflect on rational databases as well, but a lot of things that I'm going to say here you can also apply on NoSQL databases, and it will also work very good. But of course not everything. After that, I'll be spending some time talking about databases in microservice world, and basically the most part of the talk is going to be basically about the problems with data that we face in monolithic applications, but also in microservice world. At the end, there will be some time for questions, so if you have any questions, please wait until the end and ask it then. Also, I'm going to stay here for the rest of the conference, so you can just talk to me later, or you can contact me over the Twitter, mail, whatever. Also, it's not a problem. So, let me start first with a very simple question. How important is data? How much is it important for us and for you? Well, I assume that most of us are software developers, right? Who's a software developer? Yeah, most of us. So we all write code, right? We write code, we make some applications, and that's basically what we love and what we cherish, so to say. But again, we also need some data, because if we don't have data, then our applications are not going to be very useful, and not going to be very fun. Again, this data can be in database, it can be in the file system, it can be wherever, but we need it. So then, what's more important for us? Is it our application, or is our data? And to help you answer the question, ask yourself a very simple question. How annoyed you're going to be if you have a bug in an application, and how annoyed you're going to be if you have corrupted data. And also, what's going to live longer, your code or your data? The chances are that data is going to live much longer than your application, and because of that, and some other reasons, data is foundation of all applications. And let me explain a little bit more about it. So, all software follow a very simple path. Everything starts with the user. Without the user, there is no need for our application or anything else. User wants some feature, right? He wants to interact with something, and that's where actually our application comes in place. Our application provides certain features to the user, but again, in order to make rich applications, we need data, so that's why applications is sitting on top of the data. It can be database, like I said, or anything else. But the data is foundation for everything. It is the most valuable thing that we have, and it will probably outlive our code, like I said. Okay, but how is databases in the microservice world? In the old days, let's say we have a monolith, right? And the monolith would talk to a database. Very simple, right? No surprises there. Then basically when we actually split our monolith and we get a lot of microservices, we can end up with the same database, right? That's the, so to say, simplest way. We just split the application and we just leave the database behind. And what's going to happen then is that all microservices are going to talk to the same database. And this might be a problem. First of all, database will become your bottleneck, especially if your microservices start to grow much more and everybody hits the database will not be able to follow. And also, the database is a single point of failure for your whole application. If it goes down, everything goes down. So this is not good, right? Everybody agrees on this. So what some people say is that for every microservice, you should have a single database, and every microservice should talk only to its own database. But is this really the good thing or not? This is in theory. But we all know that the theory and real life are not two of the same things, right? In theory, we wouldn't have wars, we wouldn't have famine, we wouldn't have a lot of things that we have. So in real life, you can still end up with a lot of microservices talking to the same database. And this, per se, isn't a bad thing. Because again, you need to think very hard, what is the problem that you try to solve? Do you only want to have like, okay, nice blocks and nice isolated islands? Or is there a real problem that you're trying to solve? In most cases, there is a real problem that you want to solve, and then you basically need to apply solution for that problem. Not what the theory says and say, okay, like just create a lot of microservices and a lot of databases. Adjust your solution according to the real life problem. And having something like this in production can be absolutely correct and work perfectly. Okay, but now let's take a little bit more information about what the problems we encounter with data. So, the problem number one that we encounter with data is correctness. making sure that our data is correct at all time. Because like I said, the data is the most valuable thing, and if it's corrupted, everything goes to hell. So, what's the problem that we have with correctness? Well, if we have duplication of data, the same data in the multiple places, then it becomes more tricky to keep it in sync. Because we always need to remember, okay, if we update one part of the data, we also need to update the other part of the data, right? We need to keep it in sync. And again, like if your code base starts to grow, new people come in, this is very simple, very easy that we can actually forget about this, make mistake in the code, and then we have basically the same data in two places and it's different, and okay, then which one is correct, right? Is it the left or the right? Or even worse, if we have it in multiple places, then it's really become tricky finding the correct answer. So that's one of the things why the first thing when you start learning about the databases, especially in school, they teach and relationship databases, they teach you about the normalization of data. With normalization of data, basically there is a formula which says, okay, like whatever your problem is, you have this data, just follow this formula, and you will get normalized data. With the normalized data, we solve the problem of duplication because we end up with a lot of tables, and there is not a single place where actually we have duplication of data. So it's perfect for updates, right? We just update in one place, and automatically our whole system is up to the date. So we should probably all do this, right, for everything. But again, is it all in theory? Yes, but in real life, is it really good or not? Well, it depends. Imagine a very simple solution, simple problem, that you're building some application and you have, okay, you normalize the data, so you have a lot of tables, you have a lot of connections within the tables, and you need to create some very complex report. Well, what do you do? Well, because you have a lot of tables and you have complexity, then you need to do a lot of joins. And then if you have a lot of tables with a lot of data, a lot of joins, you end up with a very complex query. Very complex query means it's going to take a long time to actually produce results, which means bad response time. Again, do we want bad response time? Well, probably not. I know of real-life situation where you needed to wait for 1.5 hours to get a report, to get a revenue for all the shops. And if you're a business, you don't want to wait for 1.5 hours to actually find out how much money you have. You want like to know in milliseconds. So then, as developers, because we see this problem, what we do, well, we denormalize data. So we actually start doing opposite of normalizing data. We started creating duplications of the data throughout the application and prepare parts of the statement so we can actually run reports very fast. But you might say, okay, but if we denormalize the data, then we are back at the first place, right? Again, we have duplication of the data, which means, again, problems, what's correct data, which data should we use, things like that. So what should we do? Like, it's chicken and egg problem, right? Well, the first thing first, you need to think, okay, very hard, what your data is going to be used for. And do you need real-time value at every second and every millisecond or not? Can you use all data for something? And if you can use all data, how old? Like minutes long old, days long old, hours long? And then basically, on that, so when you think about that one use case, then the answer will come to you yourself. Like you will know, okay, like for this data I need real time, so I'm going to hit basically to have normalized data here. For this I can use stale data, so I can denormalize this part of the data, actually use it in reports, because again, like for a revenue for the whole basically company, do you need like every second correct? No, like probably last hour is more than enough. And then of course we come to a very simple thing that we need to have a single source of truth. So when you denormalize the data, you still need to have only one point where actually the truth is. And you need to protect this part, because if this part goes wrong, everything will go wrong. So actually, we just protect this for everything. We use it only where we need to use it. And in all other places, basically, we use denormalized data, and which can actually be generated from this source of truth. And again, in this case, it's much simpler solution to solve, because you have one small set that you actually are protecting, and only put the rights when actually they need to go there. And then you can have some cron jobs, bad jobs, whatever, which actually denormalize the data and populates all other data that you can use throughout your. So I know that's like, in the old days, we tried to put a lot of logic into the database itself. We store procedures and all these kind of things. But again, if you start basically breaking up your monolith, breaking up your database, it's just not going to scale, it's just not going to work. So keep as much as logic in an application, and use the database only as a dumb storage. It's going to make your life much easier. Okay, but what happens when actually at one point we have so much data for one table, so it's like one database is one table, but that table is so big that it can't fit in the memory. Well, then we have to actually do the sharding, and the sharding is, in a nutshell, simple. Basically, you have some place where you actually knows how to shard your application. You have a lot of shards, and then basically the data goes into the logic, which actually say, okay, like I know, according to this data, I'm creating the shard key, and the shard key goes to that shard, and I just send the data there. Done deal. Some databases and some people would say, okay, yeah, you should just do sharding right away, like don't split databases, like keep all the tables in one database and all these kind of things. From my personal experience, what I know is that doing sharding is not that difficult, to be honest. Doing sharding good is very difficult. So you can very easily make a lot of mistakes with the sharding, and it can cost you very dearly. So I would suggest avoid sharding as much as possible. Try everything else before, and then everything else fails, and you say, okay, like I give up, now only the sharding is left, then do the sharding. Because the idea with the sharding is that you need to first divide all the information evenly. And it can sound very easy, but it's not always the case. Especially if you have like data which is going to live for a long period of time. Also, you need to have the read load and the write load on all the shards equally. So getting the sharding key correct is a very difficult thing to do. If you do it wrongly, then basically you need to throw away everything and redo it completely, and then somehow transfer the data from your existing sharding to the new sharding, and it's really hell. So doing it is easy, but doing it in a good way, extremely hard. So that's why just this should be your last resort. Like everything else fails, then do this. Okay, so we talked about correctness. We talked about performance and size. What else is there, right? Are there any other problems? Well, evolution. Evolution of your data. And this is, I would say, probably the most difficult part, actually. Because we all know that the world is constantly changing. You know, the world of today isn't the world of tomorrow. If you think about like a few years ago, like mobile phones were not really that big. Now their mobile phones are everywhere. Like, you know, Snapchat was, I think, like what, 5, 6 years ago? Like it didn't exist, and now it's like huge. So everything is changing. The world is changing. The users are changing. The way that actually users interact with our applications is changing. The things that actually they expect for our application is changing. 10 years ago, like waiting for a few seconds to load a page, is absolutely okay. Now it has to be in milliseconds, it needs to be very huge user interface, it needs to be very interactive, or we're just going to go away and say like this website sucks, right? So because of that, because everything is changing, so are our applications. And of course, when our applications start to change, our data doesn't stay static. It also needs to evolve with time. It needs to follow the data. In most cases, like I said, your data is going to stay there, and you're going to just build a new application which is going to use the old data because you don't want to throw all the users and all the information about them just out of the window because you need some new requirements. It's much easier just build a new application and reuse the data because the data is the real value. So with this, of course, like I said, our data also needs to evolve. It needs to follow the application. But is that a big of a deal? Well, if we just look for a second, like, okay, like Monolith versus the microservice world, there is one huge difference, especially when we think about evolution of the data. In Monolith, we can stop the world. I'm not saying that it is a good thing and that we should do it. We probably shouldn't be doing that. But we can do it. It's much easier because we have just one application or like load balancers with more instances. But again, like we can just stop all of them and we know everything is down. And then we can actually just do all the changes that we need to do on the database. We can actually create new tables, update the existing tables, put the new code, whatever we want, bring everything back up, and everything is up and running again, right? So we can stop the world, for example, especially if we see that our users are not using our application in like Saturday evening, like in the midnight. So there's like 1 hour of downtime that we can have, and like we just stop the world, and nobody will probably even notice. Maybe like a few guys, but who cares? But when you move to the microservice world, that's not really an option anymore, because you have a lot of them, and you don't really know which microservice depends on which microservice. So in this case, again, you have to basically, it's much more difficult to stop the world. It's maybe even impossible to stop the world, and that's why you actually, and then even if you stop the world, then what's the point of having the microservices and having a big availability, right? So in the case of the microservice world, we can't stop the world. So we actually need to make sure that while everything is working, we can handle the evolution of the data. Okay, so let's look at evolution of data more simply like from the CRUD point of view. And then let's look every single instance of the CRUD and how it actually is going to affect us. So let's first look at reads, right? Because the reads are the most easy thing. Like we don't change anything. We just read the data, right? So how hard it can be? Well, the good thing is not that hard. Everything that I already spoke so far, basically all above, absolutely applies. Like I said, denormalization of the data where we can is a very good thing and where it actually is needed, so do it. Like I said, joining application on app level also, and this is probably the wrong place for this part of the slide, but again, like, yeah, the one thing which is very difficult when we start splitting applications and microservices and have multiple databases is actually transactions on multiple databases. Because, again, in this case, you can't have a transaction in the database because the tables are all over the place. So you need to do it on application level. And basically, you have two options. Option one is you just say everything is going to be good. I hope that everything is good. And you just make transaction per database, everything is good, and then you have some batch job or something which actually checks for your data, checks validity, and say, okay, like, oh, everything was good, and if something was bad, then you deal with it. The other option is a more difficult one, and it's actually you create in application multiple transactions on multiple databases, and then actually you implement the logic yourself in the code. So it's more tricky, but again, you need to think about the use case for your data, for what it is good, for what is not good, how your user is going to interact with it, and for what they're going to use it. But reads are usually not that difficult. Okay, what about when we want to create stuff or add stuff? Well, it turned out it's not really that difficult. Basically what we do, for example, if we want to create a table, or if we want to, for example, add a column to a table, first thing that we need to do is we just do it in the database. So we don't touch the code, we just update all the instances of the database, we wait for some amount of time, we actually make sure that everything is up and running, that everything is good, that it was propagated to all the slaves, to all the instances. And once we're 100% sure that everything is good, then we basically update the code and ship the new version of the code. And that's it. The good thing about this one is very simple. Let's say, imagine we did this, and we saw there is a bug. There's a problem. Our application isn't working as it should be working. Well, you can just roll back to the previous version of your code, which doesn't know about this new column or new table, and everything is still going to work perfectly. The fact that you have it in the database doesn't matter, because your code is just going to completely ignore it. So if you had some bug or anything, you can just drop the table, update the data, do whatever you need to do. Again, like, it's very easy to do the rollback. And that's one of the things which is very important in microservice world. We need to build our code to be forward compatible, but also backward compatible. So creating easy stuff, right? Okay, but what if we need to delete stuff? Because again, like, we all know that sometimes certain data become deprecated, so we just want to throw it away, right? We want to clean up data. We don't want to have junk laying around forever. Well, funnily enough, so let's say we want to remove the column, right? Or we want to drop the whole table. So how we do it? Funnily enough, it is completely opposite from the creating of the data, which isn't really that surprising, right? So first, we remove it in the code. So we don't touch the database. We just remove it in the code. We ship the code, and then we wait. And I don't have to say wait like a minute or 2 minutes. We wait really long time. So we need to make sure that nobody is actually referencing this data, nobody is using this data, that everything is still up and running. For example, in some companies that I used to work, we used to wait even for a month before we actually did anything else, because we wanted to make sure that there is definitely no situation that this data will ever be needed, and that all the changes that we did in the code are the good ones. Once you're 100% sure that all is good, yeah, then you basically drop it in the database or remove it in the database. Also, the good thing is when I say remove it in the code, it's a very good precaution that you just remove the reads, but all the updates that are still happening. So if you're really like, so to say, like paranoid about maybe the usage of the data, you just remove the reads, but you leave everything else of the code. So then, in the case of a problem, you can very easily roll back, and it look like nothing happened. If you're more, let's just say, like certain that it probably will not be used, then you can also remove the reads and the updates. But like I said, if you're really paranoid, leave everything except the reads. And again, like when you're 100% sure all is good, you don't have to worry about it anymore. You just drop it in the table, and that's it. You continue. Okay, but how then updates and modify? Well, one thing that people might do, especially with a monolith and stopping the world, is do something like this, right? Well, I'm changing the column name, so like who cares? Like I'll just do it in a database and that's it, right? Well, you should never do this, especially in the microservice world. It's also not really a good idea to do this in the monolith world, because again, in this case, if you make a mistake, you can't roll back. So always think, okay, can I go back? If the answer is no, then don't do it. Unless you're 100% sure that there will never be a situation where you actually would need to go back. So much better solution for you in this case, what you need to do is actually do something between the create and delete. So first, you add stuff in the database, and you actually basically add only the new column. So the old column is going to still be there. You just create the new column, which actually is going to be used. Then, of course, you add the code, and also you need to populate with the data, especially if you're going to transfer from one column to another column. You need to do migration of the data. Then also you add it in the code, but you don't really use it. You don't, the best thing would be not to read it, but you should just update it. So if somebody changed the old column that you want to actually deprecate, you update accordingly the new column also. So in both places you do the update, so that they stay in sync. Because if they don't stay in sync, you're going to have problems. Yeah, populate new code, but still don't use it. So you're still just pushing it aside, and you're not really using the data in your code. So everything still is going to use the old code, basically the old part of the system. Then, at one point when you're confident enough that you actually did everything good, you just do the switch. You use the new data, and in the case there is a problem with the new data, you log it or somehow actually inform yourself, okay, there's a problem, and then you fall back to the old data. So you still have new data and the old data at the same time. You're updating all of them, both of them. You're reading the new data, you're using new data, but if there's a problem with the new data, you fall back to the old data, and you say, okay, hi, there's a problem. There's a problem, there's some problem here, you should investigate this. I'm falling back and I shouldn't. Then, at one point when you say, okay, there are no problems anymore, every time actually I read the data, I read the new data, I used new data, and everything was perfect, then you can remove all data, but only from the code. So again, it depends on the level of the paranoia you have and how important the data is. I would suggest if it's very paranoid, remove only read data, still do the updates. Again, if there is a problem, you can again roll back to the previous version or even previous version of the previous version, but you didn't even have your complete new data in the code, and it's still going to work as it used to work. If you're not really paranoid, and you think, okay, it's going to be good, then you just remove the usage of the old code in code. Then again, wait. Wait and make sure that all is still good. Again, don't wait a minute, wait a long period of time. Week at least, month. As long as you can, as long as you need to be 100% sure that everything is good. Because again, like I said, the data is the most valuable thing. Going back with the code, it's very easy, it's very fast. Going back with the database and restoring the data which actually you lost, it's sometimes impossible and sometimes it's very tricky. And then, once you're 100% sure, I'm sure everything is good, I don't really need to worry about this anymore, everything is good, then you also remove the old data in the database. And basically that's it. So updating the data is the most difficult part, it takes the most time, it's the most painful, but you need to be very careful with it, because if you do it wrong, everything will be wrong. So basically, I spoke about the problems. Some of the most important problems are basically correctness, performance and size, and of course, evolution of data, which is the big pain. Thank you. Any questions? Or everybody wants to go to lunch? No questions? Okay. Oh, sorry. Can you just wait for Mike because I have problems hearing you.
So basically you're saying here that it's okay to have microservices who share a mutable global state. Is this right?
Yes and no. Depends.
Because you have many microservices who access the same database and they share the state. This is what I understand from the second half of your presentation.
Yeah. So the question is basically like, is it okay for microservices to share mutable state on basically changing the data? Well, again, it comes back to your use case. So sometimes it's a big no-no. Sometimes it is okay. So again, like, really depends also what you do on the data. So in theory, again, it depends how you actually structure your data. If you have basically your data in like microservices, but also the layers and the modules that you can take from one module and just put somewhere else, then you can basically create the database access layer for the database and share it between multiple microservices. And again, in that case, changing the data from multiple microservices on the same database is not always the best idea. And it's probably something that you should avoid, unless you have, again, good use case and why you say, I want to do it. The reading, for example, of the data can help. Because again, if you have one microservice here and other here, and you have like, okay, two separate databases completely separated, then this one will always have to talk to this one for getting the data. Maybe that's something that you want to do. Again, depends. Maybe you always want to, okay, hit this database, microservice from the microservice, basically get the data and propagate it. The problem is that this can take too long if you start having like A, B, C, D, and all those kind of things. So again, that's why I said, like, it depends which problem do you try to solve. If, for example, you don't care that much about certain things, but you want performance in reads, then you can just say, okay, like, I can just denormalize the data here. This one is going to only dump the data, but here can just go direct to the database and ask for it. Again, it really depends what's the problem that you try to solve. Usually, like, having the multiple microservices changing the data, same database, in most cases, it's not a good idea, but again, it really depends what's your use case. Like, I know situations in production where actually we did it, and it was good. But again, it also can go terribly wrong, because then what happened is we had actually one server which was finance server, and it was changing the finance data, but there was some other part of the system which wasn't finance. And also it had write access on this part of data, and it actually didn't understand something. So instead of going through the database layer of the Java code, which should understand the business logic, went directly to the database and created havoc. So again, depends what you want to do. But if you say, okay, read only, it should be more okay, especially if you have basically the part of a module that you can reuse in the both microservices. So in that case, all the business logic would stay the same. Again, really depends what is the use case that you want to do. So that's one of the reasons why I said on the first slide when I actually split the monolith and the theory and everything. In theory, everything should be completely isolated, completely outside of the picture, but in real life, it's not really always the good thing. And also you need to think, okay, like you have service A, which is like 99% up and running, service B, 99% up and running, service C, 99% up and running, and service D, 99% up and running, and A call B, call C, calls D, then your uptime is not 99%, it's less. So again, you need to really think, okay, like, what is the problem that I have? Is the problem availability? Is the problem database? Is the problem, what is the problem? So there is no like good or wrong answer that you can just apply everywhere and just be happy.
But if you have one monolith, the version on the left, in your picture, you have one monolith who accesses,
it will take some
here,
time.
yeah, no.
Still. Yeah.
Okay, so you have the monolith with one big database, and then you have all these services who, each of these services should have access to independent data, because if they access the same data, it doesn't make sense to be, they are no longer independent, and they are time coupled, and you can't even have the stop the world option for them, because they are two different timelines. So for me, this is like, it shouldn't happen. The blue and whatever, purple it is.
Yeah, whatever the color is. Yeah, I don't know. I didn't word the English.
Okay.
Again, in theory, you're true. You're 100% correct. In theory, this shouldn't happen. In real life, this can happen much more often than you think. And again, it doesn't always mean that it's going to be a bad thing. Also, again, it comes back to what your definition of a microservice is. Again, like how small you want for a microservice to be. If you want to really go like puristic and it just does one small thing, then you're going to have like billions of them. And again, in most cases, you're actually just going to start making your monolith smaller and smaller and smaller and smaller, and in that case, sometimes you get things like this. Again, like I said, if you think, what's the problem that you try to solve? If the problem is basically my data is too big and I want to make better performance, then you're going to split the database. And if you split the database, then you can have some table which actually multiple applications need, so they're more than going to hit one database. So it's again, like I agree. Puristically, this shouldn't happen. In real life, this happened, and it is not as bad as people think.
But it's a bad smell anyway.
Yeah.
Okay, thank you.
Welcome. Any more questions? Yep.
Yeah, my question is more business-wise than technical-wise. You said you've waited for a month just to ensure the correctness of the data. How did you convince the clients to wait that long? Because in real life, that's not realistic.
Well, the good thing about that one is that basically we were building the e-commerce website, so I was part of the IT. Actually, that's for Booking.com. So in the case of Booking.com, basically we are our clients. Clients don't know what we changed in the backend system, and we did some changes in financial data, and then again, we wanted to be 100% sure that when we ask for money from any customer or the hotel, that everything is still going to be correct. So in that case, it wasn't really that difficult because everything was inside the house, so it's easy for us to actually say, okay, we just wait for a month. Because if we screw up, then you need to find the backups, and in 1 month, especially in a huge website like Booking.com, enormous amount of things change. So you're going to have like hell on earth actually fixing the problems if there's a problem. So that's why, like I said, depends how paranoid you are. If you're not very paranoid, and if it's not really that big a problem, then you can just throw it away after a few days. But if you really are paranoid and want to be 100% sure, all is good, then everybody will really understand and say, okay, this is mission critical. It's a very simple answer, like, do you want to have a backup or not?
That's true, but I only see this applying in probably product companies, because in outsourcing, it's not that easy. I mean, it's pretty hard to convince a client to wait for a month when the project is due date in 3 weeks.
But again, it's different. Example that I gave is basically the big e-commerce website, which is going to need to store the data for a long period of time. So in that case, yeah, you don't really wait that long. In that case, you probably, again, if you want real-time updates, then you need to know what's your behavior of the user. If like say in 1-2 days you're confident and you saw all use cases, then you can do it in 1 to 3 days. Depends on. So does that answer your question?
Yes.
Okay, thank you. Any more questions? Yep.
Do you have some practical advice about how to track this waiting off while you're developing the application, making new releases, and wait for a month and then take it off, and you have a team, you don't work alone, so it's going to be quite difficult to know now it's safe to turn it off, now it's safe to do, how do you arrange that working in parallel with new development?
Well, for that, the answer is simple, more simple than you think. You need to have very good monitoring. And that's very simple. That's basically the answer. And why is like I said, you put something code, say, okay, like don't use the old one. And if you go to the old one, just throw some error for something like that. And then if you have a good monitoring, then it's going to be very easy after a certain period of time, you see, okay, like, is this error happening or not? And again, if you have a good monitoring, you will know how your users interact with your application. So if you have good monitoring, you will get basically to do basic things that you need to know for how long to wait and when it's safe. First, how much users interact with your application, how they're going to actually change stuff, things like that, and also if there are errors or not. On one case, for example, I changed some mission critical code in finance, and like in 2 days I saw that we have a huge spike basically in the queries, which are going to take a very long period of time. So users were not impacted. They were like a little annoyed because basically their response time was slower. But for me, because we had a very good monitoring, I saw right away, okay, there's a problem, so I need to go back and fix that one before I actually start removing the stuff. And in that case, I was really removing one part of very important part with a completely new setup. So again, if you have good monitoring, then it's easy. If you don't have a good monitoring, then it's not so nice. Any more questions? Any more questions? Yeah. Ooh, we have good time.
Hey, what about ACID? What do we do with ACID in microservice world?
So your question basically, if I can, if I understand you correctly, then it's this one, right? What we do when
the transactions, yeah.
yeah, with the transactions. Well, like I said, it comes back to, it's not easy thing. So again, it comes back to your use case. The problem is that, actually, the good thing is if you hit one database and one table, then you don't care, like database is going to take care of it. If you hit multiple tables, especially if there's multiple tables are over the multiple databases, then you have to implement the logic yourself. So that's a big drawback of basically of splitting the database and everything, because like when you have one monolithic database, you just hit the database and database already built all the logic about transactions, audit logs, rollbacks, everything. In this case, unfortunately, you have to throw that all through the window and you have to do it yourself. Again, two most common ways that you can actually solve this problem is first, okay, if I don't care that much about the data, so what can happen is very simply like if there is incorrect data, users will be annoyed. Then you can just say, okay, let's go happy flow. We hope everything is good. We just send to multiple tables. Everybody say just commit, 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 and then we hope that all is good. And we have a batch job which actually goes and checks the validity of the data. So that's one approach. But again, that approach doesn't work everywhere, especially with finance data. When if you and me exchange the money, then we both want to know, like, okay, like if I give the money, I want to know that you received the money, and you also, and other ways around, right? So in this case, unfortunately, you have to write the code yourself, which is going to behave like a database and multiple basically transactions. Some application actually needs to own the transaction and needs to basically do more or less like double commits way, like basically, okay, like I create, okay, transaction inside the code itself, send to all the instances that need to actually commit to the one, wait for them to confirm, check that everything is good, and if everything is good, then say, okay, all is good. And if see, okay, there's a problem, then I need to go basically and redo the stuff. And it is not easy, that's true. But again, yeah, that's the big drawback. You have to basically
You're referring to the saga pattern, right?
Sorry?
With the saga patterns, sagas?
I don't know. I'm very bad with the naming, so
Oh.
maybe. Basically, yeah, you have application which is going to play like a database god and say, okay, like, did everybody commit? Okay, everything is good. I can continue. If some of the guys says, okay, I have a problem, then you need to do the hard legwork and just go and fix everything. And it's not fun. It's very difficult. But again, it comes back to your use case and what you do. That's why I said, like, think hard. Actually, do you really need to split all the databases or not? Do you need, where actually can you, for example, what we did in Booking.com, we tried to keep all financial data in one database. Just because of that, because we didn't want to have that head, or basically to kill ourselves with that. We actually tried to keep all the tables in one database, then we had all the foreign keys, and the database did for us transactions and all those kind of things. Again, at one point you just hit the wall and you have to do it, and then it's just bite the bullet and do it, and hope that you did it good. Any more questions? Okay, in that case, thank you very much, and enjoy the lunch.